Hello and welcome to today's class. In today's class, we'll be looking at an important concept in engineering mathematics 4, which is what? Laplace transform. Alright, before now, if you have in mind that Laplace transform is a hard topic, it is not. It is very easy, right? Now, by the word Laplace transform, let's understand it in a layman term. Then we are going to bring it back to engineering, right? Now, the idea of transformation, let's say in a layman term, it simply means that you are transforming from one position to another position, right? Meaning you are changing from one position to another position. So with that being said, we can actually relate that to Laplace transform, right? To Laplace transform. So what Laplace transform does is that, though it has a lot of application when it comes to engineering, it has a lot of application, say in signal control, coding, robotics, and the likes. But our focus or our interest as far as Laplace transform is concerned is that we'll be giving several engineering problems, right? Several questions. Then the question will say that solve this using Laplace transform. So that's our focus, that's our interest. Alright, as I've said previously, I said consider Laplace transform as one of the simplest topics in engineering mathematics 4. Now, how it works is that you want to change a particular variable to another variable, right? Just like our differentiation and integration, right? Let me add this. Once you know, if you are a master of your differentiation and your integration, then Laplace transform shouldn't be a problem for you, right? It's just like you knowing a particular derivation and implement it. Alright, back to Laplace transform. I said, by definition, Laplace transform simply means changing a particular variable to another variable, meaning you are transforming a variable to a particular variable. But the two commonly variables used in this case are what? f of x and f of t. Now, how it works is that you'll be given a function f of t. The question will now say that transform this f of t given to what? F of x. Or let's say you are given a random function. Okay, consider this being a function. F of p equals to 3p plus 4. This is 1. 2. F of t is equals to 4t squared plus 2. Then 3. F of m is equals to 3m minus 4. These are functions mathematically. 1, 2, 3 are functions. This is a function of p, this is a function of t, and this is the function of m. So what you are doing in Laplace is that, or what Laplace transform does is that, you are converting this given function to another function, right? Similarly, you are converting this given function to another function. Lastly, for the third function, which is m, you are converting it from function m to another function. But the two commonly function used, or the two commonly variable used in this case, is f of t. Meaning that you are converting f of t, meaning you are transforming f of t to f of x. How do you do that? Take the Laplace. You are taking the Laplace of f of t, it will give you what? F of x. That's how it works. So now, in this case, since we understand that all we want to be doing about Laplace is that I'll be giving a function f of t, then convert it to f of x. How do I go about it? How does it work? Now, this whole process, or this whole idea, it is done with an integral formula. That's why I said, if you are a master of your differentiation and integration, you are good to go. Now, Laplace transform is defined by semi-infinite integral, which is given as integral from 0 to infinity f of t exponential negative st dt. Then you have your result as what? F of x. You then have your result as what? F of x. Now, this this integral formula looking at it, it is complex, right? It is complex, but you just need to understand it. You just need to understand it. In this case, this f of t is well defined here. We said you'll be given a function f of t. Now, let's say you are given a function f of t. Say you are given a function f of t equals to exponential 3t. The idea here is that I'm giving this function which is exponential 3t. I'm transforming this function towards f of x. I'm transforming this function to f of x. How do I get the end result, which is f of x? Take the Laplace of this given function, which is exponential 3t, using this formula. So we are saying that this formula, this is what defines the Laplace transform. How it works is that nothing is changing from this formula. All this formula, we are repeating it. Now, let's say we want to perform this. Let's say you want to perform this using this formula. It becomes what? Integral 0 to infinity. In this case, what's your f of t? F of t is given as what? Exponential 3t. You have this as what? Exponential 3t. Multiplying exponential negative st dt. And from here, by the time you take your integration, you are going to get your integral answer, which will then be a function of x. But we are going to see all this later. The basic transformation is the transformation of a constant. It is the transformation of a constant. Let's say you have f of t equals to 4, 6, 8, 9. Then transform this constant number. How do you go about this? You are going to transform this using what? Laplace transformation. So with all this, what it means is that you will be having different functions, and you have to transform these different functions given to you. So let's take the first one. This is my f of t, and this is my what? F of x. Meaning, whatever function I have here, I'll be transforming this function using this formula. And this formula says that anywhere I see f of t, I'm going to substitute the particular function I want to transform. The very first one is the transformation of a constant. Right? When f of t is equals to a. Number 2, it is the transformation of exponential. Number 3, the transformation of trigonometry transformation, where f of t is equals to cos at. The next one, where f of t is equals to sin at, then we still have more to this. F of t in some cases might be given as sin at and also given as cos at. It can also be given as t raised to power n. So what that means is that we are going to transform this function. You observe that all these functions given, they are a function of t. All these functions, they are function of t. Meaning all these functions which are function of t will be transformed to function of x. Using this what? Particular formula. So what this formula is saying is that you want to transform this first function, which is a. Anywhere you see f of t, substitute a. Perform your integration, get your end result. Number 2, you want to transform exponential negative at. What this means is that this f of t, anywhere you see f of t, substitute this, perform your integration. Then similarly for the third, the fourth, and the fifth one. So the whole idea is that you transforming a particular function, say f of t, towards f of x. So that's how it works. So let's take it from this first one and see how we can integrate to get our function fx. Now, what we want to do here is that, given this table, we want to find the transformation of this function, meaning number 1, number 2, number 3, number 4, and the last function, right? So the very first function we are going to consider, it is when your f of t, where your function is a constant. then what is the transformation of this constant, right? So bear it in mind that we want to fill up this table. And I must say this is very, very important when it comes to Laplace. This is the basis of Laplace generally, because as you go advanced, the question, there's what we call inverse Laplace, right? So you are implementing this idea towards inverse Laplace, also solving differential equation with Laplace transform. All right, let's say you are given f of t is equals to a, meaning in this case your f of t is a constant. Then you want to transform this constant to another function, meaning f of x. I said earlier that the commonly variable uses function of t and function of x, meaning f of t is transformed towards f of x, right? How do you do that? You use this semi definite integral. You use this word semi-definite integral. And what this integral is telling you that anywhere you see f of t, substitute the particular function for f of t in that case. Now, I'm giving that f of t is equals to a. I want to perform Laplace transform. I then have, repeating all this, right? I have integral 0 to infinity, right? Now, in this case, what's my f of t? I'm having a. That is, I'm substituting a multiplied by exponential negative st dt. Negative st dt. Now, from here, perform your integration. We know that from integration, I can take note from here. When I have this in integration, it means all my integral process or all my integration, it is with respect towards t. Right? Meaning from here, I want to integrate something of this nature. Then, of course, I can factor out my constant. It becomes what? A integral 0 to infinity exponential negative st dt. Negative st dt. Right? Now, let's integrate this. I'm doing this. What type of integration is this? This is definite integral. This is what definite integral. I want to believe we all watching this video, we are a 300 level student, meaning you should be able to integrate this, right? You should be able to integrate this. But let's take it back to integration. So in integration, you want to integrate something of this nature, exponential k raised to the power of x dx. Because from integration, you want to integrate something of this nature. You want to integrate something of this nature. Then the integral becomes it becomes exponential kx over k plus c. Exponential ks over k plus c. Right? Now from here, same idea. I have that a all into bracket. By the time you integrate this with respect to t, you have exponential negative st over negative s. Right? Don't forget, you are doing definite integral. By definite integral, substitute your lower and upper limit, right? Meaning you have from 0 to infinity. From 0 to infinity. Then from here, you also observe that 1 over negative x is a constant. 1 over negative x is a constant. So let's factor it out. So I have this a over negative x all into bracket exponential negative st 0 to infinity. Now from here, I have a all into bracket negative x all into bracket exponential. Now from here, anywhere you see infinity, your infinity comes first before 0. I believe you know how definite integral works, right? You know how definite integral works. For sake of simplicity, up to this level, how it works is that take this, substitute this anywhere you see t, then minus this very guy, which is what? 0. So let's see that. I'm having exponential negative x all into bracket infinity minus exponential negative x bracket 0, then close your bracket. So this is definite integral. So from here, I'm having note this. Any number multiplied by infinity is infinity. A multiplied by infinity is what? Infinity. Any number multiplied by infinity simply means what? Infinity. Exponential raised to the power of negative infinity or exponential raised to the power of infinity is equals to what? 0. Know these two guys. Now, the idea behind this is that when we say any number multiplied by infinity, simply means infinity. When you say infinity, you can consider infinity being a larger number, right? A larger number. So meaning a times a larger number, you still have what? Very large number. So that's it. So up to this level, I'm saying that I have a all divided by negative x all into brackets. This times this, of course, I have what? Exponential negative what? Infinity. Following this, so this is equation 1 and this is equation 2. So following equation 1, I have this, right? Minus any number multiplied by 0 simply means what? 0. So I have this, right? Therefore, I'm having that. Therefore, I'm having a all divided by negative x all into brackets. Following equation 2, I have 0 minus 1. Exponential raised to the power 0 is what? 1. Then from here, it becomes a all divided by negative x all into brackets 0 minus 1. What do I have? Negative 1. Open this bracket, meaning I have a over negative x times negative 1, which is equals to what? A over x. A over x. So when we defined what a Laplace transform means initially, we said Laplace transform is all about you converting a particular function, say f of t, to what? F of x, meaning you've transformed. So initially, I was given that f of t is equals to a, right? Then after performing Laplace transform, I have what? A over x. That is to say that giving a function f of t and is equals to a, this is the transformation. This is the Laplace transform. Back to our table. Given that f of t is equals to a, then the transform becomes what? A over x. A over x. So the same way you did this first guy, which is what? F of t equals to a, you apply the same process to all other functions using this very integral formula. So this is the integral formula that defines Laplace transform. That defines Laplace transform. So with that, let's take few examples. Let's take few examples. Now, have it in mind, how you see question is that find the Laplace transform. This is how you write it. The Laplace transform of f of t. Right? Meaning you are saying that the Laplace transform of f of t is equals to this integral, and the product and the answer becomes what? F of x, which we've done so far. Now, the first question, find the Laplace transform of f of 4. Number 2, find the Laplace transform of f of 10, right? Now, the first question you need to ask yourself, or first thing first, ask yourself, what type of function is this? Is this a constant function? Is this an exponential function? Is this a trigonometric function? Whatever the function it is, identify. Now, for this question, this is a constant function. This is a constant function. So by Laplace, we are saying that whenever we have a constant function, this becomes what? Transformation. This becomes the Laplace, which is what? F of x. Now, doing comparison, in this case, I'm having what? My function as a. The Laplace becomes what? A over x. Similarly, I'm having my f of t as 4, meaning the Laplace of equation 1 is equals to what? 4 over x. Meaning the Laplace of this first example is equals to what? 4 over x. What's the Laplace of number 2? What's the Laplace transformation of number 2? Correct. I have it as what? 10 over x. Can you see how it works? So go back to what we defined Laplace as. We said Laplace simply means changing from one variable, say f of t, to another variable, say what? F of x. say f of x. So generally speaking, whenever I see a function as a constant, then this is the what? Laplace transform. This is the Laplace transform. Moving on to the next one.